Hi guys, this is Miss Dixon. I hope you're all doing well. My job is going to be to teach you some math. So our math is just going to be like we do in school for math review during Slate Math. And so we're going to do all of the problems for March 18th together on your together in this video, and you can follow along with your packet. So when you take a look, I'm going to move this a little closer. When you take a look at your packet, the first problem says to write a number that meets these rules. This is one of those mystery problems. So for the mystery problems, it's important that we figure out what the largest place value is. So the first one says the value of the digit in the tens place is worth 80, 4 in the 10,000s place, 1 in the ones place, the value of the digit in the 100,000s place is 300,000, and there's 0 in the other place values. So right now you should be thinking in your head, what is the largest place value that this number has? What is the largest place value? So hopefully you're saying it's the 100,000s place, because one of the clues is talking about the 100,000s place and there's no clues talking about the millions place. So for problem number 1, the way that I would solve this and the way that would really work for a lot of us is to draw out the place values. If the largest place value is the 100,000s place, that means my number has ones, tens, hundreds. It also has thousands, 10,000s, and 100,000s. So once you've done that, the next thing that I would do is take a look at the first clue. It says the value of the digit in the tens place is worth 80. That means I have to find the tens place. So here's the ones, tens, hundreds, thousands, 10,000s, and our 100,000s. So right here is our tens place. And if it's the value of the digit is 80, I know that 8 groups of 10 has a value of 80, so I'm going to put the digit 8. Then I'm going to check off that clue because I've already used it. The next one that I have is that there's a 4 in the 10,000s place. So I've already labeled my place value, so here's the 10,000s place, and it tells me that the digit 4 needs to go there. So I can cross that one off too. 1 in the ones place. Here's my ones place. I'm going to write the 1, cross that off. The value of the digit in the 100,000s place is 300,000. So we should think for ourselves. 300,000 is the value. So that must mean that I have 3 groups of 100,000, because 3 groups of 100,000 is worth 300,000. And I cross that off. And the last one says 0 in all of the other place values. So that means that there's a 0 in the thousands place, a 0 in the hundreds place, and that's it. So the number, our mystery number that we just figured out, is 340,081. Awesome. Let's move on to number 2. Number 2 is a number line. Now when it comes to number lines, it's really important that we're thinking about, and I'm going to zoom in here a little bit closer. Oh. Perfect. When it's a number line, I have to figure out how the number line is counting, even before I answer the question. So when I take a look at this number line, I see 2,225, then there's a blank line, and then 2,275, another blank line, 2,325, another blank line, and 2,375. So this is a little bit tricky because I don't have numbers labeled right next to each other, but what I have to figure out in order to answer this question, I need to figure out the total distance between these 2 points. 2,225, and then I take a big jump to 2,275. Now in my head, I'm noticing a pattern here, and I'm seeing that I'm adding 50. Because I know that if I have 2,225 and I add 50, I get 2,275. So that's good, but now I need to label this number that comes right in the middle. Think in your head, what would I call this point on this short little number line? Hopefully you're thinking of the midpoint. The midpoint comes between the starting point and the end point on a number line. So if the total distance is 50, I know that 2,225 plus 25 is going to give me the value of this point because 25 and 25 make 50. So 2,225 is 2,250. And then if I'm at 2,250, I can add another 25 and I would get 2,275. So we just figured out that this number line, the rule for this number line is counting by 25, and we're counting up by 25. So 25 more than 2,275 is 2,300. 25 more than that is 2,325. 25 more than that is 2,350. And then I add another 25 to get to my last labeled point, 2,375. So when it comes to number lines, you have to make sure you understand how the number line is counting. So that answered part A. Our job was to fill in the missing numbers on the number line, which we just did. But now part B is asking us to put a dot where we think 2,315 would go. For this type of problem, I have to think about which two points 2,315 are between on my number line. And for this, let's see what other markers I have. For this, I know that 2,315 will be between 2,300 and 2,325. If I started at 2,300, it's 15 away where 2,315 would go, and it's about 10 away from 2,325. So that dot's going to be not exactly in the middle, but a little bit closer to 2,325. And I'm going to label it as 2,315. Awesome. So there we go. We've already answered number 1 and both parts of number 2. So now we're going to continue on to number 3. Now this is a counting problem where it's asking us to follow the directions to continue the counting for the patterns below. As you can see for each of these, and I'm going to use the board for this, so I'm going to zoom out a little bit. For each of these, the starting number is the same. 17,900, I'm double checking my work. Oh, I made a mistake. 17,898. That is my starting number. And for each time, I have to count 1, 2, 3, 4 times. So I'm going to draw 4 blanks here. 1, 2, 3, 4. The first problem is asking me to count on by tens. When I'm counting by tens, the tens place is changing. So that means the ones place will always stay the same, but the tens place and the larger place values could change. Already I'm looking at this number and I can see there's a 9 in the tens place, and I know when I'm adding one more to a group of 9, I'm going to make a group of 10 and I'm going to have to regroup. So 17,898 plus 10 means that I'm going to add one more to my tens place. So this number changes to 17,908. I had to add one more to my tens place, so one more to my tens place, which made me have to regroup. So here we are, 17,908. So again, my tens place is changing. So now my number becomes 17,918. My tens place is going to be changing again, adding one more group. So it's 17,928. And then my tens place is changing again, so it's going to be 17,938. And that's the last number that you should have for that first counting pattern. You should notice that each and every one of these numbers, when you were counting, the ones place stayed the same. And that's because when you're counting by a larger place value, the smaller place values are going to stay the same. So we're still going to be working with the same starting number for number 2, but this time they want us to count by hundreds. So I'm adding 100 4 times. You should be thinking already in your head what place value is definitely going to change and which ones are staying the same. Hopefully you realize that the hundreds place is changing and the tens and the ones will stay the same because they're smaller place values. So 17,898 plus 100 is 17,998. Just that hundreds place. Now I have to add another group of 100, and this can be tricky because I have a 9 in my hundreds place. When I have a 9 in my hundreds place and I add one more, I have to regroup. And that means I have 10 groups of 100, so I'm regrouping into my thousands place. So my next number would be 18,098. And then I'm adding another group of 100, 18,198. And then I'm adding a last group of 100, 18,298. So for this problem, those smaller place values stayed the same. 98 is 9 is in the tens place, 8 is in the ones place for each of these numbers, and you can see that right here. This is your final number. All right, the last part of my counting pattern here is that I have to start at 17,898, and I have to add 1,000. So that means the thousands place is changing. What digit is definitely going to change each and every time? The thousands digit, which is the 7. So you should be thinking too, which ones will be staying the same? I'm adding 1,000, so that has to mean that my hundreds, tens, and ones are staying the same because they're a smaller place value. So here we go. I'm setting this up. Remember, I'm just doing this on the board so you can see it better than if I was to do it in the boxes, but you should be writing this in the boxes. So 17,898 plus 1,000 means I have 18,898. Instead of 7 groups in the thousands place, I have 8 groups because I'm adding one group of 1,000 each time. The next one would be 19,898. And now again, this is a little tricky. I have a 9 in my thousands place. So if I'm adding one more group of 1,000, that means I have to regroup. And you should be thinking, what place value am I going to be regrouping 10 groups of 1,000 to? Hopefully you said it was the 10,000s place, because when I have 10 groups of 1,000, I have to regroup that into the 10,000s place, because 10 groups of 1,000 is worth 10,000. So now my number is 20,898. And my last number, adding another group of 1,000, is 21,898. So again, my hundreds, tens, and ones stayed the same because they're smaller place values. Awesome. I'm going to give you like 30 seconds as I get set up for the next problem to finish writing whatever you need to write. Okay, so we're in the back now, and we're going to do question number 4. Now, question number 4 is a word problem. Read along as I read it out loud. Mr. Scott is debating with Miss Cashin. He is telling her that 18 is an odd number because 1 is an odd number. Miss Cashin is telling him that 18 is an even number because 8 is an even number. Who is right? Explain in words and then prove it with a model and number sentence. Now, whenever I have to figure out if someone is right or wrong, or I have to give someone advice, the thing I always tell my class is that you have to do the work by yourself first. So this word problem is we have to figure out if 18 is odd or even. That's the work that we need to do. Is 18 odd or even? Now, one way that I learned how to do this, and how you learned how to do this when you were in first grade, was to draw a model of different circles, which is totally true. But as you continued in first grade, you also took the number 18 and you focused in on what place value? Hopefully, you're talking about the ones place. In order for a number to be odd, the number in the ones place has to be odd. And that's because when you split this number into expanded form, this 18 is actually 10 plus 8. We know that 10 is an even number because it ends in 0, and 0 is an even number. So all you have to focus in on is the ones place, this 8. So you can draw 8 circles. It's important when you draw your circles to make sure they're nice and neat and organized. And then with your circles, you can circle groups of 2. 2, 4, 6, 8. as you can see from this model, when everyone has every circle, I was able to put into a pair, which means a group of 2. Because of that, the number 8 is even. So I know that 18 is an even number because the 8 in the ones place is an even number. So now that we've done the work for ourselves and figured out that 18 is an even number, we should go back to the problem. And we have to figure out, well, who agrees with us? It says that Mr. Scott is debating with Miss Cashin and that Mr. Scott is telling her that 18 is an odd number because 1 is an odd number. Do we agree with Mr. Scott? Hopefully you say no. Miss Cashin is telling him that 18 is an even number because 8 is an even number. Who is right? Explain in words and then prove it with a model and a number sentence. Clearly, based off of the work that we just did, which hopefully you use this space to do so, Miss Cashin is right. But now let's practice writing an explanation in words on why Miss Cashin is right. So we're going to say, and you can do this one of 2 ways, and I'll show you both. The first way is you can talk about why Miss Cashin is right. So we're going to write Miss Cashin. It's important to make sure you use proper grammar, capital letters for proper nouns, periods at end of sentences, even when you're writing for math. Miss Cashin is right because, now in Miss Cashin's explanation, and I'm going to go back to this word problem, she talked about how 18 is even because the 8 is an even number. So we know that we have to figure, and when we're figuring out if a number is even or odd, we have to look at the ones place, and that's exactly what Miss Cashin did. So my explanation is going to talk about that. Miss Cashin is right because the number in the ones place is 8, and 8 is an even number. So far, we've just repeated what Miss Cashin has said. So now we need to add more to that to really answer this question. Miss Cashin is right because the number in the ones place is 8, and 8 is an even number. If the number in the ones place is even, then the entire number is even. And the same would be true if it was an odd number in the ones place. If the number in the ones place was odd, the whole number would be odd. But in this case, that number 8 is even. The second part of this question wants us to prove it with a model and a number sentence. Well, we already did the model, which is when we had the number 8 and we drew circles. And we circled pairs or groups of 2. And that shows that this is an even number because everyone has a buddy. What we didn't do is write a number sentence. Now, when it comes to writing a number sentence to prove it, there's only 2 number sentences that work for even numbers. The first one is a doubles fact. A doubles fact is when you add the same number twice in order to equal your total. So we need to figure what number plus that same number equals 8. This is not 8. We're going to be doing 18 because the total number is 18. So for some of you, you might already know the answer to this, but when I think about this doubles fact, what plus what equals 18, I know that 9 plus 9 equals 18. Now, for the second number sentence, we could use repeated addition. And the reason why we're going to do repeated addition is because you're talking about groups of 2. So we're going to do repeated addition with groups of 2. And I want to change my model just a little bit. Back this up a little so you can see more. My model should represent not just the number 8, but it should represent the whole number 18. So I need to draw 18 circles. Making sure you can see all 18, great. And I'm going to do the same thing, and I'm just going to circle my groups of 2. So 1, 2, 3, 4, 5, 6, 7, this is a little weird, 8, and 9. So I can use my model to write a repeated addition number sentence where I have 9 groups of 2, because this model is showing me that I have 9 groups, 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 2, 9 pairs. So I can write 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2, and I have to go down here, plus 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8 groups. I need one more to show 18. So when you're talking about even numbers, the only 2 number sentences you can use are a doubles fact or repeated addition with groups of 2. If it's an odd number, you can write any number sentence to prove it. So that one problem just took us a lot of work. It's always important when you are figuring out who is right in a problem or who is wrong. It's always important that you make sure that you are doing the work first. And that's what we did before we even answered the question in words and then showed our model and our number sentences. Awesome. So we'll take a look at the rest of this packet. Number 5 is asking us to round 693 to the nearest 10. So if I was going to round 693 to the nearest 10, I need to show my work by drawing a number line. And if I'm rounding to the nearest 10, my starting point and my end points have to be groups of 10. Groups of 10 end in 0. So there is a 9 in the tens place in this number. And so my starting point is going to be 690. And then my end point is going to be 10 more than that. 690 plus 10 is 700. Whenever I'm figuring out my midpoint, just gave away what I was going to talk about. Whenever I'm figuring out what I'm rounding to, I always need to figure out my midpoint, that number that comes between. If the total distance here is 10, that means that my midpoint is going to be 690 plus 5, because 5 plus 5 is 10. So 690 plus 5 is 695. So now I can take a look at my number line and think, where does this number 693 come between? And I know 693 comes between 690 and 695 on this number line, probably somewhere here, and I'm going to label it. If I started at my starting point and went to 693, I would be adding on 3. If I started at 693 and went to my end point, I would have to add on 7. So when I think about if I'm rounding down or rounding up, I have to think about which one I'm closer to. And it's easier for me to make 3 jumps instead of making 7 jumps, so I would round down to 690. All right, the next question is asking us to round the same number, 693, to the nearest 100. This time, I'm focusing in on that 100 when I draw my number line. My starting point and my end point have to be groups of 100. So my starting point would be 600, my end point would be 700. And I still have to figure out my midpoint. I know my midpoint is halfway between 600 and 700. That means what's halfway between what's half of 100? Half of 100 is, hopefully you said 50. So my midpoint is 650. That would be a jump of 50 from 600 to 650, 650 to 700, another jump of 50. So 693, what 2 points on this number line does 693 fall? Well, 693 falls between 650 and 700. So that means that I have to figure out where it belongs on this side. 693, that 90 is telling me that it's close to 700, about here. So 693 to get to 700, I would just have to jump 7 times. But if I was at 600 and wanted to jump all the way to 693, I would have to jump 93 times. So which one is it closer to? 600 or 700? Hopefully you said 700. 7 jumps is way easier than 93. So it's closer to 700. For number 7, our job is to write two numbers that would also round to the same group of 100. So that means, and I'm just going to turn this off so we don't get bothered by it. That means that I have to figure out all of the numbers that could either round up or round down to 700. So the way I like to think about this is another number line, but it's a little different because right in the middle is 700. Thinking about all of the rules, I know that any number from 650 to 700 would all round up to 700. And any number from 749 and down would all round down to 700. So you can tell me a number between 650 and 749 and you would be right. But I always like to say, don't make it too hard for yourself. To figure out a number that rounds up to 700, just take away 1 and you get 699. To figure out another number that might round down to 700, just add 1 and you'll get 701. Keep it easy, don't make it too challenging. But again, your answers could be any numbers between 650 and 749. Awesome. This last one, I'm going to put up my paper on the board to make it a little bit easier. And this last one is asking us to figure out what half of these numbers are. So, when it comes to figuring out halves, that means I need to figure out the doubles fact of these numbers. And I've told my class that it's super easy to figure out half of numbers when the whole number is even. That means when the digit in the tens place is even and the digit in the ones place. So take a look at these numbers. Which one would you start with? Hopefully you would say half of 40 because 40 has an even number in the tens and the ones. So half of 4 in 40 is 2 and half of 0 is 0. So half of 40 is 20. The next one that I would do is right next door, half of 42. Half of 4 in the tens place is 2 and half of 2 is 1. So half of 42 is 21. That means that 21 plus 21 equals 42. The next one I would do would be 44. Half of 4 in the tens place is 2. Half of 4 in the ones place is 2. So half of 44 is 22. 22 plus 22 equals 44. We just split that into 2 equal parts. Now let's go back over here. When we're figuring out what half of 36 is, it's important to think of this number in terms of its tens and its ones. Back this up. 36 is really the number 30 plus 6, expanded form. Half of 30, that's the tricky one. I have to think about half of 30 and this is one of those things that some of us have memorized and some of us haven't. But half of 30 equals 15 because 15 plus 15 equals 30. And then half of 6 equals 3. So when I add these two numbers together, I get 18. And half of 36 is 18. 18 plus 18 equals 36. The last problem we have is to figure out what half of 38 is. So half of 38, I'm going to do the same thing. That's really thinking 30 plus 8. Half of 30, we just figured it out, is 15. Half of 8 is 4. 15 plus 4 equals 19. So half of 38 is 19. Those are a little bit tricky, but as we keep practicing them, and we'll be practicing this as review for a while now, it'll get easier and easier. Awesome. Well, that's all I have for you for math today. I will see you guys tomorrow.